So here we have a clock. Today we're going to look at the hands of the clock and try to figure out the angle measures. So right now we have the hands are showing 6 o'clock. Okay, and we want to figure out how many degrees that is. Well, if we think about rotating once around a circle, or if a skateboarder spins around once, or a snowboarder spins around once, we've really rotated 360 degrees. There's 360 degrees in a circle. So right now at 6 o'clock, we're splitting the circle in half. So that means here we have 180 degrees or a straight line. Okay, some other familiar fractions, if we look at 9 o'clock, we can see that that's 1/4 of the circle. Or you could know that 360 divided by 4 is 90. That's a 90-degree angle. Okay, maybe you're familiar with 8 o'clock. See how we have, wait, 1/3 here. So 360 divided by 3 will give us 120 if we were looking at 8 o'clock. But it gets a little trickier if we were looking at 7 o'clock. So we could think about how each of these numbers splits the clock into congruent slices. It's like having 12 same size slices of pie. So if you're looking at the hands formed by 7 and 12, we have 1, got 1, 2, 3, 4, 5 of the 12 pieces of pie, sections on the clock, of the 360 degrees. So if we multiplied that together, we'd end up with 150. Or you could think about how each section of the clock is 1/12. Why is that yellow? Sorry, is 1/12. Each section's 1/12 of the 360. So each little slice there is really 30 degrees. And if each of these is 30 degrees and we added them all up or multiplied by 5, we'd get the same 150 degrees. Okay, so it's fairly simple when it's an o'clock answer. It's 7 o'clock or it's 3 o'clock. Those answers are easy to find. But if we think about time and we start moving our minute hand here, sometimes the hour hand does not point directly at the number. So let's try 7:30. We want to figure out the angle measure when the hands point at 7:30. So I'm going to break this up into 2 sections here. So we have from 7 to 6 and this in-between portion here, in between 7 and 8. So we should know that between any two numbers on the clock, we just found out was 30 degrees. Now, we don't know how many degrees we're at between the 7 and the 8. But if we think about the minutes that we've traveled, we've gone 30 minutes out of the 60 minutes in an hour. That's 1/2. So that means we're 1/2 between the 7 and the 8. So what's 1/2 of the 30? because between 7 and 8 there's 30 degrees, but we only traveled half that way. Well, that's 15 degrees. So between the 6 and the 7 was 30 degrees. Between the 7 and the minute hand, we were halfway between, sorry, between the 7 and the hour hand, we were halfway between the 7 and the 8, so that's 15 degrees. If we add those up, we're at 45 degrees. So at 7:30, the hands make a 45-degree angle. Okay, let's try one more example. Let's say, oops. Okay, let's say we were at 8:15. We're trying to figure out this angle measure. So from the 3 to the 4, that's 30 degrees. From the 4 to the 5, that's another 30 degrees. From the 5 to the 6, that's another 30 degrees. 6 to 7, it's 30 degrees. 7 to 8 is another 30 degrees. And then we're partially past the 8. We're trying to figure out this chunk right here in red. Okay, so we're at 15 minutes. 15 minutes out of the hour is the same as 1/4. That means we're 1/4 the distance between the 8 and the 9. 8 and the 9. So if between the 8 and the 9 was 30 degrees, we're now only traveling 1/4 that distance. 1/4 times 40, or sorry, 1/4 times 30 is 7.5. So this little section here was just 7.5 degrees. So if we add all that up, we're taking 30 plus 30 plus 30 plus 30 plus 30. So that's 150 plus 7.5 to give us 157.5 degrees. And that's the angle made here in red.